So this question is another resistance graph question. It starts off asking you to draw this circuit. And so the marking is, there'd be one mark for drawing the voltmeter in parallel with component X, another mark for drawing the ammeter in series with component X, and it wants you to use the circuit as a potential divider, so this is the final marking point here, connecting like that. Then it asks, it's all about this graph question, so then it asks, well, here's the voltage characteristics for current against current for component X. It's connected to a cell of 2 volts with it named internal resistance, and it says use the graph to show that the resistance of X is 0.83 ohms. So what you need to do, using the graph, read off the voltage at 2, and it gives you a current of 2.4 amps, so current of 2.4 amps at a voltage of 2, and then just using R equals V over I, you get 0.83 ohms. So that's the easy part of that question. If I now show you the second part to this question, and just put it on the bottom here, it now says a resistor of resistance 1 ohm is connected in series with the cell and with component X. Use the graph to deduce that the current in the circuit is 1.3 amps. Well, there's a few ways to approach this, but this is one way. The PD across the 1 ohm resistor will be 1.3 volts because it's the current times the resistance. So based on that, if it's in series with X, the remainder must be 0.7 volts across component X. Now you need to show that this is true on the graph. So the way to do that, if you go across here onto the graph, 0.7 volts, if that's across X, it should give you a current of 1.3 amps, and it does. So that's consistent with what you just calculated, and that would be the final marking point.